Chapter 13, question 23, asks you to describe the similarities and differences between cellulose and glycogen. So to put this in context, we started with the monosaccharides. Those are the fundamental building blocks of sugars or carbohydrates. And there were three of those that you would want to know. You would want to know glucose, you would want to know galactose, and you would want to know fructose. Glucose is blood sugar, galactose is in milk products as a part of lactose, and fructose is fruit sugar. So those were the monosaccharides. Then we started talking about the disaccharides. The disaccharides are what you get when you connect two monosaccharides. And you want to be familiar with three of those: maltose, lactose, and sucrose. And you'd want to know which monosaccharides those are made up of and what type of glycosidic bond connects the two monosaccharides for each of those. Now, if you start connecting more than two monosaccharides, you get polysaccharides. And that is what cellulose and glycogen are. So this problem is dealing with the polysaccharides. Okay. Now, they're asking for two things. They're asking for similarities and differences. So first, similarities. So the similarity you'd want to know is that both of these, both cellulose and glycogen, this should be glycogen, both cellulose and glycogen are made of glucose. So both of them are just really, really long chains of hundreds of thousands of glucose rings. Cellulose and glycogen, both. So that's what they have in common. How about differences? They're different in several ways. So here we have cellulose, and then let's compare that with, or contrast that with glycogen. So cellulose, first is the glucose units are connected by beta 1,4 glycosidic bonds. In glycogen, the glucose, the long strings of glucose, each glucose is connected to the next one by alpha 1,4 glycosidic bonds. In cellulose, there's little to no branching. And that means that these long chains can line up really well with each other, and the H's on one can line up with the O's on the other. The H's are slightly positive, the O's are slightly negative. It creates lots and lots of hydrogen bonds, and that can make cellulose really, really hard. In fact, wood is made of cellulose. It's lots and lots of hydrogen bonding between two strands of straight strands of cellulose that makes wood as hard as it is. Glycogen, on the other hand, has lots of branching. Glycogen is how animals store glucose in your muscles. In fact, the O-gen means you can produce, and glyc is referring to glucose. So you can produce glucose from this glycogen. Animals store glucose in their muscles for when you need it. Say you need to do some activity, but you haven't eaten for a while. Your body can take the glucose from the glycogen stored in your muscles, and it branches a lot so that it can store more of it. And then last but not least, you want to know that cellulose is used as a structural component in plants. So we were just talking about wood, and glycogen is used for energy storage in animals. So there you have some similarities and differences for cellulose and glycogen, the two polysaccharides.